This set of slides looks at the process for determining the asset allocation. So here are the 4 steps. Determine the asset allocations that meet the investor's return requirements. Second, eliminate asset allocations that fail to meet quantitative risk objectives or are otherwise inconsistent with the investor's risk tolerance. Third, eliminate asset allocations that fail to meet the investor's constraints. And fourth, evaluate the expected risk-adjusted performance and diversification attributes of each allocation and select the most attractive. It's important that this evaluation is on an after-tax basis. Alright, so here we have some data. We have a series of asset classes and their projected total returns and expected standard deviations. Now, when you're gathering your data, you can simply base your projected total return on an average of past returns over the longest period that you can get. And the same with expected standard deviations, they can be based on an average of standard deviations over the past 20 years or so. And that data is relatively easy to get. In reality, what we should be doing is taking those averages, adding our own forecasts, incorporating forecasts about the future with inflation and the economy and various other factors, and adjusting those average figures to what we expect. But simply, the simplest way to do it is just to take past averages. Right, so we have cash equivalents. For example, projected total return is 4.5% and expected deviation is 2.5%. And as we go down the page, for the most part, we get a bit riskier to venture capital, which is 26% total return, but it has a 64% standard deviation. And standard deviation is riskiness. It's the deviation from the average. And over here we have 5 portfolios, theoretical portfolios of the asset allocation mixes. So portfolio A, for example, allocates 10% to cash equivalents, 0% to corporate bonds, 40% to municipal bonds, 20% to large cap stocks, 10% to small cap stocks, 10% to international stocks, 10% to real estate investment trusts, and 0% to venture capital, and they all total to 100%. So it's a mixture of percentages allocated to each type of asset class, and notice that they're not all of the asset classes are covered. And when we get on to doing mean variance portfolio techniques, you'll see how we can use programs to help determine these asset allocations. So these are hypothetical portfolios that we might consider. Over this page we have a summary of that data. So for portfolio A, we have a total expected return of 9.9%, an expected after-tax total return of 7.4%, an expected standard deviation of 9.4%, a Sharpe ratio of 0.574, which is a measure commonly used to describe the performance of portfolios, a nominal expected return of 9.9%, and an expected real after-tax return of 3.4%. And I'm going to show you how to calculate these expected real after-tax returns, and this is what we base our return objective on. Do these portfolios meet the investor's return objective? So step 1, and we return to the case study of Susan Fairfax. So she has stated that she is seeking a 3% real after-tax return. The first table provides nominal pre-tax figures that must be adjusted. Now there are 2 methods to adjusting these pre-tax figures. This is one. It's not the easiest one. The next one is the easiest one, but I'll go through this. A simple approach is to subtract the municipal bond return component from the nominal expected return, then subject the resulting figure to a 35% tax rate and add back tax-exempt municipal bond income. That calculation produces a nominal after-tax return from which the expected 4% per year inflation rate is subtracted to arrive at the real after-tax return. For example, portfolio A has an expected real after-tax return of 3.4%, calculated by the 9.9% is the nominal expected return, minus municipal bond rate of return times the inflation rate, in big brackets, multiplied by 1 minus the tax rate of 35%, plus the municipal bond rate times the inflation rate, work out the bracket, minus 4%, inflation rate gives us 3.4%. Another way to work it out is that the return can be calculated by multiplying the taxable returns by their allocations, summing these products, adjusting for the tax rate, adding the result to the product of the non-taxable municipal bond returns and its allocation, and deducting the inflation rate from this sum. For example, allocation A, if you go back to the first table and you look at the percentages allocated to each asset class, it's 4.5% to cash. The return is 4.5% to cash, and there's 10% allocated to portfolio A. It's 13% return to large cap stocks times 20% allocated to portfolio A, plus 15% return to small cap stocks times 10% allocated to portfolio A, plus 15% return to international stocks times 10% in portfolio A, plus 10% return to real estate investment trusts times 10% allocated in portfolio A, multiplied by 1 minus the tax rate of 35%, plus the municipal bond returns of 7.2% times the inflation rate minus the inflation rate gives us 3.5%. And if we go back to table 2, when we've worked out these expected real after-tax returns for each portfolio, we need a portfolio that's over 3%, so portfolio A, portfolio B, portfolio D, and portfolio E all meet those return objectives, but portfolio C does not. So we eliminate portfolio C, or we potentially eliminate them. Okay, step 2 is risk tolerance. So Fairfax has stated that the worst case nominal return of minus 10% in any 12-month period would be acceptable. The expected return less 2 times the portfolio risk, which is the expected standard deviation, is a reasonable baseline measure of shortfall risk. So this is a rule of thumb, 2 times the expected standard deviation, which is what we subtract from the expected return. So if the resulting number is above the client's threshold level, the criterion is met. So let's have a look at that. So the expected return of portfolio A is 9.9%. Expected standard deviation was 9.4%. 2 times 9.4 is 18.8. So if we subtract 18.8% from 9.9%, then we get the worst case return of minus 8.9%. The same calculation is done for all portfolios. Now what we need to do is make sure it's not more than minus 10%. So portfolio A is okay, portfolio C is okay, and portfolio E is okay. But we have already eliminated portfolio C, so we're just left with A and E. Yes, portfolio A and E. Both meet the stated constraints of Fairfax and neither is eliminated in this step. So you go back to the constraints that we listed and compare to make sure that they meet the constraints with liquidity, tax, regulatory burdens, etc. Step 4. Risk-adjusted performance and diversification evaluation. So finally, we decide on portfolio A, and this is why. So both A and E have similar expected real after-tax returns. Both A and E have large exposures to municipal bonds. E, however, has a large position in real estate investment trust stocks, whereas A has large equity allocation to diversified portfolios of large and small cap domestic stocks. Hence, A provides greater diversification. Furthermore, there is more uncertainty in real estate investment trust projected returns than in the small and large cap stocks, and we can be more confident in selecting A that the return and risk objectives will be met.